Let's not rush and start with an interesting fact. Did you know with our current space technology and our fastest rocket available, by the time I finish this 10-minute TEDx talk, we will have traveled about 11,000 miles through the space, and yet that big number isn't even enough to leave the Earth's atmosphere. And in fact, if you left for Mars, starting from the second I step onto the stage, by the time we reach Mars, uh, we will, I will have finished this talk about 38,000 times, and yet that's a calculated number. In case you didn't understand what's the problem here, let me try and illustrate it to you. Imagine for a second that you have to travel from Baku to Nakhchivan, but like instead of a car, someone just hands you a single pair of hiking boots, like this one on the screen, all covered in dirt. And believe it or not, that's exactly how we are trying to reach Mars today. You see, we have spent 6 years perfecting the same hiking boots over and over again, like making the laces lighter or the soles prettier, but at the end of the day, we're just still walking, aren't we? Of course, it's slow, it's exhausting, and it's also why we haven't really gone anywhere since 1972. Nowadays, if we want to reach another planet, we use chemical rockets like this one on the screen. Think of it like a giant garden hose where you spray the holes at the ground at a steady, constant rate to push yourself upwards, like basically to fly. And in the engineering world, we measure how good an engine is by its efficiency, basically how much push we get for every pound of fuel we carry. And the problem is, chemical rockets have hit a wall on this actually. You see, we have reached the maximum efficiency the chemistry allows, and just because of that, our rockets are extremely expensive and takes about 9 months to reach Mars. Like, we're talking about 9 months. That isn't space exploration. That's just a 9-month trip in a tiny metal box with no windows or no way to stop for air. Like, I don't want to spend my 20s waiting in a tiny tin can. I want to find a way to reach the stars that actually matches the scale of our ambition. And the hilarious part is that we actually came up with a good idea that was cancelled a long time ago, like in 1958. Meet the Project Orion. Scientists call it the nuclear pulse propulsion, as you can see on the screen, but I like to call it the nuclear power stick. Now, the word nuclear usually makes people think of disaster movies or world ruiners, but as someone who wants to build a future, I believe we should look at the physics, not the fear. And to understand why this is the most powerful engine ever designed, you don't need to have an aerospace engineering degree. You only need to understand the mechanisms of a pogo stick. Yeah, right, a pogo stick. A pogo stick is a really simple machine, like it only consists of a foot plate, a spring that acts like a shock absorber, and a rider. To move forward, you don't spray the hose at the ground, you use the pulse of energy. Basically, you compress a spring, release the force, and just like that, you move forward. In the late 1950s, the world's smartest physicists all gathered and realized that if you want to move a massive city block-sized ship, you can't just spray the hose at the ground, we need to do jump, and they came up with a build. The design was bold. You would build a massive ship with a massive steel plate, which was also a pusher plate at the bottom, and drop small energy pellets, which are tiny nuclear bombs actually, and then, boom. The energy would hit the steel plate and the shock absorbers would soak up all the violent kicks so the astronauts inside don't turn into a strawberry jam. And just like that, the whole ship, all 10,000 tons of it, just leaps forward, like jumps forward. And then you would do one jump every second. It explodes, explodes, and explodes until it reaches an unimaginable speed. And the math behind this actually changed everything. Like, a chemical rocket is just like walking. You're limited by how much weight you carry until it's too heavy to even lift itself up. But nuclear power stick is just like being shot out of a cannon. Like, we are talking about reaching to Mars in weeks instead of months as we calculated. We are talking about reaching to Saturn in the time it takes to finish a school semester, and that's why I would prefer the nuclear power stick any day. And then you might ask a very good question. Since the science is working and the math is mathing, why am I showing you the picture of a power stick and the 3D designs of it instead of the real launch itself? And the fact is, it never happened. But the final boss of this engineering story, the wall, wasn't the physics, nor the math, nor the engineering part of this. It was a piece of paper. Yeah, a piece of paper. In 1963, the world signed a treaty that banned all nuclear explosions in our orbit, which cancelled Project Orion. And actually, it made sense back in the day, like people were terrified of radiation falling out of the sky since it was in the middle of a Cold War. But the truth is, the people who wrote that treaty were only solving the problems of that day. They weren't thinking about today, they weren't thinking about our future. And that's where I believe the plan needs to change. You see, if we build these ships on Moon and launch it from Moon, we actually basically just solve our problem. You see, there's no air to pollute that Moon, and there's no way the radiation reaches our atmosphere from that distance. And actually, by using Moon as our shipyard, we make the things more efficient. But as I mentioned before, just because of the 6-year-old law, the Project Orion was cancelled, and it became illegal to build one engine that could lead us to the stars. And that's where the autopilot mode becomes the real problem. What I mean by autopilot mode is that we accept these rules as they were the unchangeable rules of our nature, but the truth is they aren't. They're just choices we made up a long time ago without thinking about our future. Like my generation is being told every day that space is too hard, space is too expensive. It's only hard because we're using the wrong engines. It's only expensive because we're using the wrong fuel. We need to look at the history books and ask ourselves that, are these laws actually protecting us or just holding us back from the stars? We have the physics, we have the mechanics. We just need to stop walking and take the courage to make the first jump and actually design what we are capable of, which are more than that. And thank you for listening.